Okay, what you see here is a circular lens. This could be a circular shallow dish full of water with transparent sides. It could even be part of a bottle where the sides are nice and circular. I can sort of trace around the circumference of this disc. Now I've got the laser pointer here, and I'm going to put a beam through the disc. Now I want to adjust the beam. I'll kind of tip this up and down a little bit to make sure that the beam is coming in straight along, straight parallel to these lines on the paper. Okay, now there it's nice and parallel. Need to switch hands, make sure it's still parallel. No, it's been adjusted a little bit. Okay, that's pretty well parallel to the lines. Now I mark the origin of the beam here. I carefully mark the point where it enters the disc, the point where it exits, and another point out along the exiting beam. Now let's see here. I didn't really get that one marked very accurately. There we go. That's better. Okay. Now I move over a little bit, and again make sure the beam comes in nice and parallel. Okay, I kind of adjust this thing, make sure that beam there is parallel to the lines. Set the thing down, mark the origin of the beam, the point of entry, point of exit, and a point along the beam. I should be labeling these points, and when you do this experiment you will want to label the points for sure. Okay, get the beam parallel, mark its point of entry, point of exit, and a point along the beam. Now using a straight edge, I'll just use a cassette case again for a straight edge. I mark the path of the beam as it goes into the disc. As it passes through to the other side of the disc, and as it passes out of the disc. There's the first beam, the second, passing into the disc, through the disc, and out of the disc. And the third into the disc, through the disc, and out of the disc. We see that these beams all seem to converge at a point that's right about here. I find this very surprising. I've never measured what's called the index of refraction of this disc, but I've just discovered something. Let's put the disc down here and see if what I think is true really is true. It seems that if I run parallel beams into this disc, Maybe I'm surprised because I didn't mark these points very well. Actually, I traced these rays wrong. Okay, that would have been a big surprise. The reason this would have been a big surprise is if the focus is here, it turns out that this, what I thought was an acrylic disc, is really made out of solid diamond, which is about the only substance that would bend the light enough to make that happen. It's going to be a little bit awkward, but I'm going to try to fix the picture. Okay, if I draw this and this, and then I draw this and this, which are the accurate paths. You might not be able to see this too well because I've got too many rays here, but we see that the three parallel rays that came in here seem to converge at this point. That is, again, something of a surprise, but not as much as before. Now, this indicates that we have a much higher index of refraction than I thought we should, but if I move this beam along here and keep it parallel to the straight lines, we see that the beams do tend to want to converge right here. If I put a screen at this point or something to detect the beams, and let's try this, we see that all the beams do tend to converge at this point, which is kind of interesting. This point turns out to be only a small fraction of the radius, maybe a third of the radius, on the other side of this circle, whereas I thought that it might be about equal to the radius on the other side, which is what happens if I do the same experiment with water. Okay, of course there's Mountain Dew in here. We can see that the point of focus for the Mountain Dew is about here. Okay, hopefully you can see how the point of focus on this strip of paper here doesn't change much as I move back and forth. If I get in closer, it moves along with the beam. If I get further away, it moves opposite to the beam. This is because each ray comes to a point that's right about here. Now let's see where it is. Yeah, I think the point is right about here for the Mountain Dew. The surface of the Mountain Dew bottle is right about here. And this distance is about equal to the radius of the circle. Now we'll see what's going on with these diagrams a little more clearly when we look at a good picture.